Okay, so welcome to today's training. And today is our last class about 6 week series training. And we will open the online exam from tomorrow. And you guys will have 1 week to finish it. So now let's start our today's content. Today I will introduce EtherCAT single axis control, some relative function block, and some EtherCAT configuration and axis configuration. Some content will be similar to our last class because, for example, the axis configuration is almost same. So first, why we need EtherCAT control? Because to my opinion, for EtherCAT control have these four advantages compared with post axis. First, EtherCAT, through EtherCAT, our PLC can connect more axis control. For post control, because we need high-speed post output, so it will have hardware limit in PLC. But for EtherCAT, we control the driver through communication, so we can connect, for example, 6 can support up to 128 EtherCAT axes. So, and also for the wiring, we don't need to connect pulse direction signal from PLC to driver. So the wiring is more simpler and neater. And the last, because all our axis is controlled through every EtherCAT communication cycle. So EtherCAT control will have higher synchronization. So this is some advantages, I think, why we need EtherCAT control. And now go back to our software interface. First, we need to how to create the EtherCAT axis. Here we can directly right-click and select the information device decryption file to insert the slave station. And our PLC have built in this file. It's a VD3 driver and EtherCAT coupler. If you want to connect third part driver, you need to click this import and import the device decryption file to PLC and add it. And here, after we insert the EtherCAT solution, here we automatic created one motion axis, and this motion axis is default bound to this EtherCAT station, slave station. Here is VD3 driver. So we can right click to add it. And also, if you have many driver, you can connect them one by one first and use this scan device to scan the connected device and click this copy all and click save. So it can automatic to add all EtherCAT slaves. And so you don't need to add them one by one. So here we have two ways to create the EtherCAT axis. And here, if we double click the EtherCAT here. If you double click here, this station, you will get this EtherCAT configuration interface. And let's introduce these windows one by one. First is process data. This process data is, you can understand it's the data exchange between PLC and the driver. And we need to select one group of output parameter and one group of input parameter. Here, the output parameter is the data we need to send from PLC to the driver. And the input data is the parameter feedback from the driver to our PLC. So you can see here, for output, we need to output the target position, the mode, operation mode, and the control mode. We need to send this command to our driver. And for driver side, it will feedback some parameter. For example, the status mode, current position, actual position, and actual torque, and some other parameter. Later, I will show you how to these two group. You can see this group, the parameter is default, and if you want to add or delete it, we need to enable one setting, and I will introduce it later. Then usually for these two group for parameter in these two group, we usually add the parameter which we need it updates in every cycle. Then we need to add this parameter to these two group. And if the parameter some data, we don't need to exchange them between driver and the PLC in every cycle. Please don't add that to our PDO to this process data. We can use another instruction called SDO read and write. We can use that instruction to change this value. Something like RS instruction in 5V series. And here, IO mapping. You can see here we select some list two group and get this variable. And here we can create its variable in our project and bind this variable to this object dictionary. And so we can monitor this value during the project running, and also we can display this value in our HMI or some other device. And here, for each object dictionary, it have a data type, and we need to bind the same type variable. Start parameter. Start parameter is this parameter will be written to the driver when the EtherCAT is activate. It's something like SM102 system register. This parameter will be write to the driver only one time when the driver is after initiate. So you can see here for the the mode of operation, default operation is 8, and 8 is our CSP, cyclically synchronous position control mode. So you will see usually default when the driver is turn on, you will see 88 NF on the servo panel, and the 18 means this CSP control. Here, if you want to modify the process data, you can here have this in select parameters have one enable expert parameter. After enable this, you will get this expert process data, this window. And here, these two group with this its mark means we select these two groups. One is one group input and one group output. And you can add the object dictionary to these two groups according to your to your requirement. For example, if you use touch pop function, then you need to add some, for example, touch pop launch position uh, parameter to these two group to get the uh, recording value. Okay, and in axis configuration, here if you don't have driver, you can enable these virtual axis modes. So you can test it without the driver connecting. And sometimes we may use this virtual axis as our master axis and make the slave axis with the and connect the slave axis as the actual driver to do some for example eCam or e-gear function, e-gear motion. Okay, so and for other axis configuration, for example, unit conversion setting and this online debugging and homing setting, this is same with the post axis. So here we can skip this introduce. And now let's check the and now I will show you some widely used relative function block with single axis control. For example, these three measurement function block: MC power, MC read actual position, and MC read actual velocity. This is used to enable the driver and read the position and the velocity of our driver. Here I put this this system register SM1902. This is our EtherCAT start flag. It means this flag will turn on when the PLC communicate successfully with all EtherCAT driver. And yes, and here with these two function block, we can the data, the position and the velocity data will be updated in every sync cycle. And how to and where we can set the sync cycle. You can set here. Double click this EtherCAT. And here have the sync unit cycle. Default is 1 ms. And we have some, for now, we have already opened it to 250 0.25 ms in some special software. But for website software, the default the smaller sync cycle it should be 1 ms, and this value should be adjusted according to the axis we connected. Usually for eight axes connected, we suggest to set this as 1 ms. And for example, if you connect 32, 32 axis, we suggest you set this value to 4 ms. Okay, so with the default setting, this position and the velocity will update in every 1 ms. For the here, for each MC function block, we have this axis ID, and this axis ID is here. You can see in motion control axis, we have this number. 0 is yes. It's a little different with AC60 because in AC60 we can bunch the axis name to the function block. But in 6V, we need to bunch the number of an axis. And in here, MC power, you can see these two interface, these two inputs, enable positive and enable negative. Usually we set true of these two inputs. If you find your driver can only rotate in one direction or can't rotate, maybe you didn't set on these two inputs. And also another two management function block, MC set position and MC reset. For MC set position, we can enter the setting position and enable this instruction to write the position to our driver. You can see here the position is changed to 10. This function block will not move your motor. It's change the position in software side. So yes. And also we have this MC reset function block. This function block can clear both the EtherCAT communication error and the driver side error. But before you reset axis, you need to ensure the error have been already cleared. For example, if the encoder axis, if the encoder cable is disconnected, and you didn't inset or you didn't change the encoder axis, encoder cable, this can't reset. This function block can't reset the error. Okay. And now I will introduce some motion function block. For example, here we have jog function block, relative move and absolute move. Like DDRVI and DDRVA instruction in 5V series. And okay, so I think this parameter is easy to understand. For example, for MC move jog, we have jog forward and jog backward two direction, and jog speed, acceleration, deceleration. And for these two positioning function block, we have target distance and also running velocity, acceleration and deceleration. For the buffer mode, I will introduce it later. So we can directly check this video. First, enable the driver and read the position and the velocity. Use this function to jog our driver. Jog forward and jog backward. These two, jog forward and jog backward, couldn't couldn't turn on together. Otherwise, the function block will report error. And now let's run this relative move. Move forward 10 units position. And absolute move to 0 position. Okay, so this three function block is the basis motion function block. And some other motion function block, for example, stop and home. We can use this MC stop to stop the current movements. For example, you triggered some e-stop button, and then you can use this function block to stop your axis with a big deceleration. And after this function block finishes, the status of the axis will be changed to standstill status. This is one status of our driver, and our axis will have many status. I will show it later. And also, MC home is used to do the homing operation. We have introduced it in our last class. Here for in MC stop function block, this deceleration value should be bigger than 0. If you set it at 0 and run this function block, you will also get an error. This is the homing mode. You can select the homing mode in axis configuration and use the function block, MC function block to do it. Okay, this is same with post axis. Okay, we can continue. Skip these parts. Okay, now here is the motion. Here is the motion status of our axis. You can use this read status function block to get the current axis status from this output side. So you can see we have arrow stop, disabled, stopping, homing, standstill, and some other motion status. And this standstill is one of them. And on the left side, you can see this picture. This picture shows how to change between two, for example, between two axis status. For example, you can see here when you run this MC stop function block, the status will be changed to this stopping status. And when the MC stop finishes, the status will change to this standstill. And when you run this, for example, when you run this MC move absolute or MC move relative, the status will change to this status. This creates motion. And if you run this, for example, MC move velocity, this function block, the status will change from standstill to this continue motion. These two difference is for continue motion, it means the axis will always running until you stop, use MC stop it. But for this, for example, MC absolute, the axis will stop when axis achieve the target position. So it's not continuous motion. And if an axis, for example, if we set this axis as the left, and it internal synchronize status with a master through in or came in. The status will change to this synchronized motion. Okay. You see, after power on, it's stand still. And when we run this smooth relative, it change to this discrete motion. Discrete motion, and when we run this MC stop, it will change to stopping status. And it will keep stopping status until you turn off. Turn off this until you turn off this execute input of MC stop. Okay, now the state change to standstill. And when I run this MC home, you will see this homing status will turn on. And it will turn back to standstill after the homing is finished. Here, because I set the homing mode as 35, so it will take the current position as the home position directly. Okay, so as for the you can see here, for most ocean function block will have this buffer mode. This buffer mode means with a moment. Okay, here. uh, Here we have these buffer modes. Six type buffer modes. The buffer mode is used to easily understand. The buffer mode is used to how to say? It's used to switching from one function block to another function block. For example, we are run this for now. We run this move relative function block, and during this function block running, we execute another move relative function block. If we set it as 0, it means the first function block will be stopped, and the PLC will execute this second function block to finish it the remind motion. This is for first one, 0. And you set it as 1, it means, for example, when you trigger function block 1 and then trigger function block 2, the motion will like this. When the first function block finish it, then begin to execute the second function block. So this is the 0 and 1. And for other modes, you can see here, basically this picture will be more how to say, more clear to see how it works. Here, with this buffer modes, it will wait in the current motion, finish it, and then begin the uh, next uh, next command and some other introduce for different buffer modes. I will also share this presentation to our group later, and you can check it in details for the buffer mode. Okay. Okay, so this is our today's content. If you have our VD3 driver or other EtherCAT driver in your site, you can connect it to 6V and to test some function block I introduced today. If you have no driver, it doesn't matter. Uh you can set the EtherCAT axis as virtual axis in axis configuration here. And then you can also test this function block. Okay, now you can think if you have question, you can type here